All right, here's the second part. We're actually going to do the same thing, and you can take a look at the commutative diagram. So let's practice one more time all by yourself. If you can go to the next page, do that, to construct all the diagram. And the last equation, nk is 0, that thing is the same. Just you practicing this one more time. And we're going to see where this one's coming from. Was it? Good? Okay. So we're calculating the order. This argument is not about, one-way direction. We're just calculating. This is a lot easier, actually, seems. So we're raising to the nth power. We're looking for smallest n, right? That's it. That simple as that. What we're looking for is that you raise that a to the k to the nth power, and this is equivalent condition. So we're looking for smallest n that makes this equation satisfied, positive. So if I switch to congruent, so k is fixed, right? And n is unknown. We're looking for smallest n. The 0 modulo t. You do the same thing. You don't have to assume the greatest common divisor is greater than 1. We just write it. Greatest common divisor of d, d is what and what? The coefficient and the modulus, right? And t is there. And what is the coefficient here? What is unknown? Unknown is n. Coefficient is k, right? So these two is d there. So if you want to cancel, and then the k is dk prime, write the same thing, and t is a dt prime. And you know k prime and t prime is relatively prime, right? Because you factor out all that. So this one reduces to back and forth equivalently, that n is unknown, and k prime times d is congruent to 0 modulus t prime times d, right? Whenever you see a common factor in the coefficient and the modulus, and that divides the other side, you can cancel those, and then it's an equivalent equation. Then it's nk prime is congruent to 0, that knocked down there, right? This is equivalent condition. Now k prime and t prime, relatively prime, right? Therefore, its multiplicative inverse exist. And here's a trick question. Z mod in what world? Not Z mod t. Because you were doing the Z mod t prime world here, right? Therefore, it had to be Z mod t prime. The modulus t prime here, right? So therefore, that what is next part? Multiplicative inverse is multiplied there, right? Multiplicative inverse is multiplied, and 0 is always there, 0. Then it says n must be 0 mod t prime. Is that right? So what the conclusion is that if nk is 0 mod t, if and only if n is 0 mod t prime. That's what we proved. Does that make sense? So that's a lot easier to see. What is the smallest positive integer? That satisfies this one. The smallest n is n t prime, right? T prime. So t prime. 0 doesn't work. Next one that hits 0 is the first multiple of t prime, which is t prime. So t prime is t divided by what? D, right? Vector out there. What is d? D was greatest common divisor of t and k, right? The coefficient part that with the modulus. That's how you quickly calculate. So if you would have done this one first, then this would be really easy, right? That where is it? This would have been a lot easier. What is the order of this ak? Relatively prime is 1. Order is t. So this length of this t is the set of the original. It must be the same thing. It's a lot easier argument. Just wanted to go through this commutative diagram 2 times. That was it. So this is our exercise. Order of third